Thank you very much, fellow Kenyans. Good afternoon. This is Honorable Babu Owino, Member of Parliament in Kcse East constituency. Today we'll be handling Kcse mathematics revision on vectors. Last time I handled vectors as a topic, and I promised that I will deal with questions on vectors. The reason why we are handling these questions is because in the next Kcse examination, vectors will never miss. In fact, vectors will be set, and I believe that this is one of the topics that shall contribute to our students scoring a mean grade of A plane. Specifically in mathematics, I believe that when you handle these vectors well, then you already have secured your A plane. Moving forward, we have decided to change with the changes that has been made by the CS Education, that is Professor George Albert Magoa Omore. And I will be communicating to you as the lessons are going on the changes that we shall make moving forward. For now, stay tuned and enjoy your lesson. This is your favorite son, Babu Owino. Thank you very much. Hope you enjoy this lesson. And in between, I'll be making the announcement that I wanted to make. Very special, important, and also urgent. TBIM. So it's mathematics, vectors. Today is 11th of July, the year of the Lord. This year so many things have really happened, but yaliondwele sipiti. So on to our first question, that is given the column vectors A, given the column vectors A equals to 1 minus 2, 1, and B equals to 6 minus 3, 9, C equals to minus 3, 2, 3, and that P equals to 2A minus a third B plus C. Then you are told express P as a column vector. That's 2 marks. Express P as a column vector. Class, when you're given such a question, just the way it is, just write P equals to 2. Then A, what is our A? Just replace where there is A, you replace with 1 minus 2, 1, as it is here, minus a third. B, what is our B? 6 minus 3, 9. Then plus C, what is our C? Minus 3, 2, 3. So our P equals to 2 times 1 is 2, 2 times minus 2 is minus 4, then 2 times 1 is 2. Then minus, when you are given here a third times B, so it is a third times every number here. So a third times 6 is 2, then a third times minus 3 is minus 1, then a third times 9 is 3. Then plus minus 3, 2, 3. So P equals to, by BODMAS, bracket of division, multiplication, addition, and subtraction. Therefore, addition comes first. So if you are given such a challenge, then you apply BODMAS. So we will add this, which is 2 minus 4, 2. We add it 2, add 2, minus 3, 2, 1. So that is 2 minus 4, 2, plus the value here is minus 3, 2, 3. Then you subtract this value, which is 2 minus 1, 3. So from here, 2 plus minus 3 is the same as 2 minus 3, which is minus 1. Just here. 2 minus 3. 2 plus minus 3 is 2 minus 3, which is minus 1. Okay, from here, minus 1. Then minus 4 plus 2 is the same as 2 minus 4, which is minus 2. Then 2 plus 3 is 5. This minus, the value here is 2 minus 1, 3. So from here, what do we get? Minus 1 minus 2 is minus 3. Then minus 2 minus minus 1 is the same as minus 2 plus 1, which is 1 minus 2, gives you minus 1. Then 5 minus 3 is 2. So our value of P in column vector form is minus 3, minus 1, and 2. So you must be very careful with the signs once again. You add this to this is minus 1, that is minus 1, then minus 2, then 5. Then you subtract 2 minus 1, 3. This is minus 3. 1 minus 2 is minus 1. 5 minus 3 is 2. So this is what you get. Then the next question on that, you are part B, determine the magnitude of P. Determine the magnitude of P. So this is the value of P. So in getting the magnitude of P, you write it as P with that sign to show the magnitude, then minus 3, minus 1, 2. You put that sign. That sign means magnitude or length or modulus. So when getting the magnitude of P, just square this, square individual numbers, minus 3 squared plus, then you add 2, minus 1 squared plus 2 squared into the square root. So the modulus of P equals to minus 3 squared is minus 3 times minus 3, which is 9, plus minus 1 squared is 1, plus 2 squared is 4. So this is the square root of 14. So our answer is the square root of 14 units. The square root of 14 is 3.752, is it? If I'm not wrong, just confirm for me. Let me use my calculator, but confirm this. Square root of 14 is 3.752. Is it? Just confirm for me in your calculator. (3.742), not 52 but 42. Sijakuwa mzee sana kwa hesabu. So that's our answer for that. As easy as that. I think my felt pens. Tafutie nyingine hapo inafanya vizuri. Now the next question. Given points P, that's question number 2. Given points P, minus 6, minus 3. Then point Q, minus 2, minus 1. And then point R is 6, 3. So express PQ. Now these are points, different points. So you are told to express PQ as a column vector. Last time when I was telling you, PQ means Q minus P, as simple as that. So PQ means Q minus P. Now Q is minus 2, 1. In column vector form, you write it minus 2, 1. Then minus P. P is minus 6, minus 3. Therefore, PQ in column vector form is minus 2 minus minus 6, which is minus 2 plus 6, which is 6 minus 2. That is 4. Then minus 1 minus minus 3. So it is 3, minus and minus is plus. So it is 3 minus 1, which is 2. So PQ in column vector is 4, 2. And you harvest your answer, you harvest your mark. And then you are also told to express QR. as a column vector. QR means R minus Q. R is 6, 3 minus Q. Q is minus 2 minus 1. So what do we get? 6 minus minus 2 is 6 plus 2, which is 8. Then 3 minus minus 1 is 3 plus 1, which is 4. So QR is 8, 4 in column vector form. So you are told, hence show that P, Q, and R are collinear. P, Q, and R are collinear. So we said for points to be collinear means they lie on the same line. For them to lie on the same line, you say PQ is a scalar multiple of QR. So PQ we already have. You show that they are parallel first, because lines, if they are moving on the same direction, which means that they are parallel. For them to be parallel, it must satisfy this condition, where PQ is a scalar multiple of QR, or PR is a scalar multiple of QR. So in our case, we have PQ, just replace PQ here is 4, 2, equals to the scalar of QR. What is our QR? QR here is 8, 4. So open up the bracket. This is going to be 4. 4 equals to 8t and 2 equals to 4t. So therefore from these two, t equals to a half. This is 4 over 8 or 2 over 4, which is a half. So you write it nicely from here. You say PQ equals to a half, which is t of QR. Therefore, PQ is a scalar multiple, is a half of QR, or QR is equal to 2 of PQ. So after getting this condition, the second condition for collinearity is that you identify a common point, and the common point in PQ and QR is Q. So you state Q is a common point. Therefore, P, Q, R are collinear. As easy as this, class. This is very easy. You are harvesting free marks in Kcse. So the next question, the position vectors of x is given by 2i plus j minus 3k. These questions are from the past Kcse examination papers. That is from 1989. 1989, I was just 2 years old. So we decided to compile various different questions to help you, and the setting style is just the same. So you are given x equals to, this is question 3, x equals to 2i plus j minus 3k, and y equals 3i plus 2j minus 2k. Then you are told find xy as a column vector. Look, find xy as a column vector. Xy means y minus x, but you are given these are called unit vectors, I, j, k. So x in column vector form is 2, 1, you take them with their signs, 2, 1, I, j, k, 2, 1 minus 3. And y equals to I, j, k, 3, 2 minus 2. Therefore, if they want xy is y minus x. So y is 3, 2 minus 2. Then you subtract x. X is 2, 1 minus 3. So this is 3 minus 2 is 1. 2 minus 1 is 1. And minus 2 minus minus 3 is the same as minus 2 plus 3, which is 3 minus 2, which is 1. So in column vector form is that. This in unit vector form, this is our answer. So we are done with that question. But this in unit vector form is I plus j, 1i plus 1j, which is the same as I plus j plus k. But in column vector form, this is unit vector. This is column vector. And we are done with that question. And you harvest your 3 marks. Next question. Given that A equals to 1, 2, B equals to minus 4, 5, C equals to 3 minus 2, then you are told that P equals to 2A plus B minus 3C. Find the modulus of P. So if you are given such, just come to where P is, just write P equals to 2, but what is our A? A is 1, 2, plus B, what is our B? Minus 4, 5, minus 3C, what is our C? 3 minus 2. So our P is 2 times 1, just open the bracket, is 2, 2 times 2 is 4, plus minus 4, 5, minus 3 times 3 is 9, 3 times minus 2 is minus 6. So P equals to, BODMAS, you add this 2, then you subtract this. So 2 plus minus 4 is 2 minus 4, which is minus 2. Then 4 plus 5 is 9. Minus 9 minus 6. So this comes to P equals to minus 2 minus 9 is minus 11. Then 9 minus minus 6 is 9 plus 6, which is 15. So our P in column vector form is minus 11, 15. But we are told to find the modulus of P. So the modulus of P, or the length of P, equals to that. You replace that with that sign. So simply the modulus of P equals to minus 11 squared plus 15 squared into the square root. So the modulus of P equals to 11 times 11 minus 11 times minus 11 is 121, plus 15 squared is 225 into the square root. So this comes to This comes to 121 plus 225. This is 346, the square root of 346. This is 17. Is it? Just find out the square root of 346. 17, it should be that. The square root, this comes to 17 units. 17 times 17, 49, huh? 18.6, sorry. 18.6. This is 289. So it's not 17, but it's 18.6. Then you add units. As easy as that. So another question, just another question. The position vectors AB, where A is given by the position vector in coordinates form is 2, 5, and B 8 minus 7. So these are 2 points AB. Then you are told find M, find the coordinates remember, not position vector, but find the coordinates of M, which divides AB in the ratio of 1:2. So our M is there. It divides this in the ratio of 1 into, ratio is 1 into 1 to 2. So we want the coordinates of M. So when you are given such a challenge, just come from the point O, origin, just make an extension. So OA is given by 2, 5. OB is given by 8, 7. So what is OM? So you just write here OM. How do you move from O to M? O to M is O to A plus A to M. So OM equals to O to A is given by 2, 5. You are given here, plus AM. AM is the ratio 1 over the total ratio, which is 1 over 3. Total ratio is 1 plus 2 is 3 of AB. Therefore, OM equals to 2 over 5 plus a third of AB. AB means B minus A, but our B is 8 minus 7. 8 minus 7, then minus A, our A is 2, 5. So OM equals to 2, 5 plus a third into 8 minus 2 is 6, then minus 7 minus 5 is minus 12. When you open the bracket, OM equals to 2, 5 plus a third will multiply every number in the column vector form. So a third times 6 is 2. Then a third times minus 12 is minus 4. Therefore, OM equals to 2 plus 2 is 4. Then 5 plus minus 4, which is 5 minus 4 is 1. So the column vector of OM is 4, 1, but the coordinates of M, point M, coordinates of point M is 4, 1. If you write in coordinates form, is 4, 1, where 4 represents the value of x axis and 1 represents the value of y axis. So it's as easy as that. So when suppose we want to use the ratio theorem on this, so what do? It's very short. Using the ratio theorem, 2 over the total ratio, you just start with 1. Start with 1 over the total ratio, which is 1 over 3 of value of B. That is so let's just follow this as simple as this. This is okay. So let's when you're obtaining it, because it is 3 marks, when you use the ratio theorem, it's going to be very short and it will not generate the full marks, because it should be this value over this, you add to this value over this, which is just one step, so it won't give you the 3 marks. So for you to obtain the 3 marks, you have to follow this procedure. So the coordinates of point M is 4, 1. So next one is, because of the marks that are given here, I don't want to mislead you, because the step is going to be very short. It's just one step and it's going to give you only 1 mark. So the ratio theorem will just give you 1 mark there. So the next question, you are told OA equals to 2I minus 4K. And OB equals to minus 2I plus J minus K. Then you are told to find the modulus of AB. Find the modulus or the length or the magnitude of AB. AB means B minus A. But what is our OA? Our OA equals to 2I. There is a J, because 2I, J, then K. So what is our J value? 0. Then what is our K value? Minus 4. Whereas OB equals to 2I, which is minus 2, J is 1, and value for K is minus 1. Therefore, AB means B minus A. So B minus A. So our B is minus 2, 1 minus 1. Then minus A, which is 2, 0, minus 4. What do we get? Minus 2 is minus 4. Then 1 minus 0 is 1. Then minus 1 minus minus 4, which is minus 1 plus 4, which is 4 minus 1, which is 3. Therefore, the modulus of AB equals to our value here, column vector form, minus 4, 1, 3. Then you introduce the two parallel signs. So AB modulus equals to, we square every number here, then we add them and find the square root. So that is minus 4 squared plus 1 squared plus 3 squared, everything into the square root. So AB modulus, minus 4 squared is minus 4 times minus 4, which is 16, plus 1 squared is 1, plus 3 squared is 9. So this is the square root. AB equals to 26, square root of 26. So the square root of 26 is 5 point. Square root of 26 is 5 point. 5.099, 5.099 units. So that's it. That's as easy as this. Look at the way this topic is so easy. Now you are told, show that point P, which is 4, 0, minus 4, Q, which is 8, 2, 1, and R, which is 24, 10, 11. Show that these points are collinear. Show that these points are collinear. So we said that for them to be collinear, then we say point PQ is a scalar multiple of point Q R. So PQ is Q minus P. So Q is 8, 2, 1 minus P. P is 404 equals to T of QR, means R minus Q. R is 24, 10, 11 minus Q, which is 8, 2, 1. So let's open the brackets. 8 minus 4 is 4. 2 minus 0 is 2. 1 minus 4 is minus 3. Equals to T into 24 minus 8 is 16. 10 minus 2 is 6. And 11 minus 1 is 10. So open this further. 4 equals to 16T. 2 equals to 60. And minus 3 equals to 10T. So here when you open up is a quarter, T here is a quarter, while T here is a third, while T here is minus 3 over 10. Therefore, if you get different values of T, and I gave this example so that we can obtain a different value of t, so that I tell you how you conclude. So when you do it like this, it's not necessarily that examination will make you, the question will give a common value of t. If the t is not common, if it's not a quarter, 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 or a third, a third, a third, or minus 3 over 10, minus 3 over 10, minus 3 over 10, then the conclusion is point P, Q, R are not collinear. Points P, Q, R are not collinear. Okay? So you can go over it again. You check the signs. That's it. No, this is 8. 10 minus 2 is 8. Be careful with the signs. 10 minus 2 is 8. 11 minus 1 is 10. Then from here, PQ is Q minus P. Q is 821 minus P. P is 40 minus 4. Class, be very careful with the signs. Be very careful with the signs. So, remember if I left this sign and I also subtracted wrongly 10 minus 2, I said it's 6, but it's 8. So just come here. 8 minus 4 is 4. 2 minus 0 is 2. Then 1 minus minus 4 is 5. Not minus 3. Is 5. This is like plus 5, which is 5. So here we have 4, 2, 5. 4, 2, then 5, not minus 3. Then here we have 16t. 24 minus 8 is 16. 10 minus 2 is 8. 11 minus 1 is 10. So this is 16t. You open up. 4 equals to 16t. 2 equals to 8t. 8, not 6. Be careful. Then here 5 equals to 10t. Remember, we got different values of t. Suppose they were different, then you conclude by saying P, Q, R are collinear. So in our case, they are going to be the same. Let's cross this. So 4 equals to 16t. Here t equals to a quarter, that is 4 over 16. Then here 2 equals to 8t. T equals to a quarter. Then here lastly 5 equals to 10t. So t equals to 5 over 10, which is a half. So it's still coming out to be different. Let's check again. So you have to take care of these signs. So let's check the last one. PQ is Q minus P. This is 1 minus 4 is 5. Then 11 minus 1 is 10. So still it's not coming out. So it's not quarter, quarter, and a quarter. So the points are not collinear. But you have to keep on checking, because suppose you get that they are not collinear, you have to go through your work again so that you confirm, because you can make a mistake when it comes to the signs. So the signs matter a lot. So I think that's it. So the points are still not collinear. Suppose they were quarter, quarter, and quarter, we would have concluded by saying P, Q, and R are collinear. Then you identify a common point, which is point Q. So exactly, class. So they are not collinear. So that's it. So if you find like that, then you just conclude by saying that those points are not collinear. The next question, very fast. Given that P equals to 2i minus j plus k, then Q equals to I plus j plus 2k. Then you are told to determine a half P minus 2q. They want you to get the modulus of a half p minus 2q. So here, just come here and say a half of p. Our p value is 2. Remember to write it in column vector form. 2i, which is 2, minus j, which is minus 1. Then k is also 1. Then minus 2 of q. Our q value is 1i, 1j, and 2k. So this comes to a half. A half times 2 is 1. Then a half times minus 1 is minus a half. Then a half times 1 is a half. Minus 2 times 1 is 2. 2 times 1 is 2. 2 times 2 is 4. So what do we get here? 1 minus 2 is minus 1. Then a half minus a half minus 1 is minus 1 and a half, which is minus 3 over 2. Then a half minus 4 is minus a half minus 4. You must be sure of your signs. I'm just trying to oversimplify this. So a half minus 4, get the LCM, which is 2. So 2 goes into 2 ones, that is 1 minus. This goes here, 1 goes here twice, 2 times 4 is 8. So this is 1 minus 8 is minus 7 over 2. So here is minus 7 over 2. But they want the modulus. Are you seeing these signs? So if they want the modulus is minus 1, minus 3 over 2, then minus 7 over 2 into that sign. What does this mean? It means minus 1 squared plus minus 3 over 2 squared plus minus 7 over 2 squared. Everything into the square root. So this comes to minus 1 squared is 1 plus minus 3 over 2 squared is 9 over 4. You square 3, then you square 2. So 3 squared is 9 plus 2 squared is 4 plus minus 7 over 2 squared is 49 over 4. Then into the square root. So this get the LCM, which is 4. 1 goes into 4, 4 times. 4 times 1 is 4 plus 4 into 4 once, 1 times 9 is 9 plus 4 into 4 once, 1 times 49 is 49. So this is 58, 62. So this is 62 over 4. 2 here, twice, 2 here, 31. So this is the square root. What we want is the square root of 31 over 2. So square root of 31 over 2 is the same as square root of 15.5. So what is the square root of 15.5 is 3 point? What? 31 divided by 2 is what? Now, 3.937 units. So that's it. Remember, you don't leave your answer at this stage where you say square root of 15.5. You simplify it, you solve it. Okay? So now the next question, this one normally comes, will come as 10 marks in examination. So you be careful here as we solve this. So as we solve this, in a triangle OAB, we have a triangle here. So our triangle is O, A, B. Then you are told M and N are points on OA, OA, there's a point M, and OB, there's a point N. So M and N are points on OA and OB respectively, such that OM, O to M, and M to A is in the ratio of 2 to 3. O to A, O to M, OM to MA is in the ratio of 2 is to 3. And ON, ratio NB is 2 is to 1. ON, remember the direction moves from O to A, then O to B. O to N, then N to B is in the ratio of 2 is to 1. And BM, AN, just draw that line, AN, arrow that way, AN, and BM intersect at a point X. Given that OA equals to A, OA is A, and OB is B. You just move with the direction the way it's moving. Express in terms of A and B, BM. Express in terms of A and B, BM. So don't panic, class. When you see such a question, just follow the instructions. Just move as the question demands. So they want BM. So how do you move from B to M? B to M. So when you want to move from B to M, you can move from B to O, then move from O to M. So BM equals to B to O, O to B is B. B to O, you are moving the reverse, which is negative B, plus OM. OM is 2, which is the total ratio, 5, 2 over 5 of OA, but OA is A. So this is our BM. Then you are told again, find, that is the first part of the equation, and you harvest your marks. The second part is find AN. AN, A to N. How do you move from A to N? You can move from A to N going from A to O, then go from O to N. So AN equals to A to O if O to A is A. A to O is the reverse. You are changing direction, which is negative A, plus O to N. O to N, O to N is the ratio here is 2. O to N is 2 over the total ratio, which is 3 of OB, but OB is B. You've harvested another mark. By taking BX, BX equals to T of BM. Be careful here. Just follow the instructions and it will lead you to your answer. Bx is equal to T of Bm, where Ax equals to H of An, where T and H are scalars. Express Ox in two different ways. Express Ox. So Ox in two different ways. Ox, O to X. O to X. You just draw a line O to X from O to X. So how do we move from O to X? So we can move from O to X by moving from O to B and then moving from B to X. So when you open this up, O to X And again, another OX, you can follow this route or follow this route. So when you follow this route, OX equals to OA plus AX. So this is as simple as it sounds. So O to X, we want to find these two values of O to X, then we equate them, then we solve the values for the scalars. Then we shall have finished this equation. So O to X, the first O to X, this is 1, this is 2. So let's find O to X1, which is OB. OB is B plus BX. BX class, you are told BX is equal to T of BM. T of BM. Therefore, OX equals to B plus T of BM. BM is here. BM. BM is given by, you already solved it here, which is minus B plus 2 over 5 of A. So when you open this up, OX equals to B. Use scalar T to open the bracket, will be minus TB plus T minus plus T times minus B is minus TB plus 2 over 5 of TA. So further simplify this, OX equals to, common factor here is B into 1 minus T plus 2 over 5 of A. That is one value for OX. Then again use this other root for OX. So this is 1. Then again OX for 2. The second one you say OX is OA. OA is A plus AX. AX. Our AX is given here as H of AN. So OX equals to A plus H of AN. What is AN? AN is here. You already solved it up here. Into, which is minus A plus 2 over 3 of B. So when you open this, you simplify it. OX equals to A. H times minus A is minus HA plus H times 2 over 3, B is 2 over 3, HB. Then simplify, OX equals to, common factor here is A into 1 minus H plus 2 over 3, HB. So this is OX2, this is another OX. So this OX1, this OX2. Therefore, OX equals to OX. So this equals to this. What do we get here? This OX, which is B into 1 minus T, equals to 2 over, no, plus 2 over 5 of A. So this OX equals to this OX, which is A into 1 minus H plus 2 over 3 HB. So this is 2 over 5 of TA. So this is 2 over 5 of TA. So when you have that, you equate them. Therefore, this value of B on this side equals to the value of B on the other side. So you say B into 1 minus T equals to, the value of B here is 2 over 3 H of B. This is one equation. The next equation, value of A here equals to value of A here, which is 2 over 5 of TA equals to A into 1 minus H. This is another equation. So this forms two simultaneous equations. So this B cancels this B. So here you remain with 1 minus t equals to 2 over 3 h. And here you get this a goes with this a. So here you get 2 over 5 of t equals to 1 minus h. So these are two simultaneous equations. Make h the subject of the formula from here. So if we make either h or t, so if we make t the subject of the formula from here, then you get t equals to 1 minus 2 over 3 h. When 2 over 3 crosses the other side becomes a minus. So 1 minus 2 over 3 h, t crosses the other side becomes a plus. So where there is t in the second equation, you replace with this value. So here we get 2 over 5 of t, but our t here is 1 minus 2 over 3 of h equals to 1 minus h. So when we simplify this, cross multiply both sides by 5. So when you cross multiply this side by 5, you get 2 into 1 minus 2 over 3 of h equals to 5 into 1 minus h. So you open up the brackets. So this becomes 2. 2 times 1 is 2. 2 times minus 2 over 3 is minus 4 over 3h equals to 5 times 1 is 5 minus 5h. Then collect the like terms, bring h on one side, minus 5h when it crosses the other side becomes plus 5h, then minus 4 over 3h equals to this 5. 2 crosses the other side becomes minus 2. So solve this. LCM is 3. 1 into 3, 3 times 5 is 15h minus 3 into 3 once times 4 is 4h equals to 3 minus 2, 5 minus 2 is 3. So this you get 11h over 3 equals to 3. Multiply both sides by 3. So 11h equals to 9. Therefore 11h equals to 9. Therefore h equals to 9 over 11. So after getting h as 9 over 11, what is our value of t? Our value of t, simply replace where h is with 11 over 9. So you come here and say 2 over 5t equals to 1 minus h, which is 9 over 11. So solve this side. LCM is 11. 1 into 11, 11 times 1 is 11, minus 11 into 11 once times 9 is 9. So 2 over 5 of t equals to 2 over 11. When you solve this, you get this. So cross multiply. So t equals to 2 over 11 times multiplied by the reciprocal, which is 5 over 2. So our value of t is 5 over 11. So you are told to express OX in two different ways. So from the previous example here, from the previous working, we said OX in two different ways. So where there is h, the first way here, OX here, therefore becomes OX equals to OB, which is B. Our first value here is B, plus T of BM. Our T, we have our T. Simply just where there is OX, where there is T, replace the value of T here, and where there is H, replace the value of H here. So let's replace it together. We have our T as 5 over 11. So our first value of OX equals to A into 1 minus H. Our H value is 9 over 11 plus 2 over 3 of H is 9 over 11 of B. So when you simplify this, you get, that is 11 minus 9, is 2 over 11 of A plus 3 here, 1, 3 here, 3 times. 3 times 2 is 6 over 11 of B. So this is our first value of OX. You simply replace where there is OX, you equate it to this value, then you replace the value for H and you replace the value for T. So when we replace the value of T, what will we get? In this form, our OX again, second value for OX equals to B of 1 minus T. B into 1 minus T, our T is 9 over 11. T is 5 over 11 plus 2 over 5 of TA, that is 2 over 5. Our T is 5 over 11 of A. So OX equals to, this is 6 over 11 of B when you simplify this, plus 2 over 11 of A. So we've expressed OX in two different ways, and you can prove that this OX is 2 over 11 of A plus 6 over 11 of B is the same as 6 over 11 of B plus 2 over 11 of A. So that's as easy as that. So most of the times, class, such a question comes, but it comes with 10 marks. So we will do the last question, and before we do that last question, I want to talk about the issue of what the CS proposed. He said that the schools will be opened by next year. So that's still quite a long time. So we decided as a class, myself together with my team together with myself, we decided that we are going to be we'll be proceeding with our lessons, with our tutorials. But we are going to engage other teachers who will be teaching, different teachers who will be teaching various subjects. For example, next week we'll be dealing with biology. So I want us to give other teachers an opportunity to make use of their talents, so that at least they can share whatever they have, whatever information, whatever knowledge they have with our students. And I'm assuring you once again that we are going to handle all the subjects. We are going to handle languages, we are going to handle religious studies, including IRE and CRE, and we are also going to handle physics, biology, all the subjects. So next weekend we'll be dealing with biology. And some of the lessons will be recorded, so we'll just be playing the recorded lessons, while other lessons will be live. We are also working on a platform where students from various parts of the country will access our work on an application, an app, or a web. So both of them will be working in tandem, that is the web and the app. You will just subscribe and you will get the content that you need. You will get our tutorials, you will get short notes on various topics, you will get every other content that you need, examination, past questions from the past papers, way from 1989, where some of you were not yet born. I think just as a joke, probably dad was still vibing mom. So we are going to get all our contents together in one in one application, which we are developing as we are speaking. We'll also be organizing contests. There will be maths contest, there will be biology contest, and the top students will be rewarded. This application will also use it to provide scholarship for our students. We'll be providing bursaries for our students. Those students who will pass well, we will be sponsoring them to the university level. Those students who will be average performers, we'll also sponsor them to various colleges. We will ensure that we revolutionize education in this nation. So kindly just stick with me. Those who will be lacking fees, we shall provide that fee using our platform. So just follow us. Parents, don't get worried about where school fee will come from. We know that we have the Almighty God, the God of abundance. If we are the children of the Most High, then definitely we have nothing to fear. For the Bible says that you should fear not. If we are the head and not the tail. The harvest shall be provided for by the Almighty God. Let's finish our last question, and then we call it a day. This is an easy one. Find scalars m, that is 4, 3. Find scalars m and n such that m into 4, 3 plus n into minus 3, 2 equals to 5, 8. So just open this bracket. M times 4 is 4m, m times 3 is 3m, plus n times minus 3 is minus 3n, then n times 2 is plus 2n equals to 5, 8. So this is simply simultaneous equation. So with this, we can solve it by elimination method. Multiply this by 3 by 4. So this is 12m, again 12m, minus 3 times 3n is 9n, equals to 3 times 5 is 15. 4 times 3 is 12m. 4 times 2n is plus 8n, equals to 4 times 8 is 32. 12m minus 12m is 0. Then minus 9n minus 8n is minus 17n, equals to 15 minus 32 is minus 17. So n equals to minus 17 divided by minus 17, which is 1. Therefore, by substitution, we substitute where n is 1, we replace 1 here. So 3m plus 2 into 1 equals to 8. So 3n equals to 8 minus 2. 3n equals to 6. N equals to 6 divided by 3, which is 2. So our values for m is, our values for n, this is m, not n, this is m. So our value for n is 1 and m is 2. So class, our class is as simple as that. I think those are the only possible questions that can be set in vectors. There is also an external division of a line which can come and which will come. So I want to take this opportunity to thank you very much for the lesson and appreciate you for your time. Let's stay positive. Let's pray for each other and let's forgive each other. May God bless you. Asanteni sana na tuseme ni tibim. For those who are going to church today, the SDA, happy Sabbath, happy day. For those who will be going to church tomorrow like myself, tuko pamoja na tupange kazi. Asanteni sana. For seek ye unto the kingdom of God and everything shall be added unto you, including knowledge. Asante.